Welcome to Maths for You YouTube channel. A past question on integration, finding area under curve. This is an Oxford and Cambridge board question. The diagram about the curve y for cos 2x divided by 3 minus sine 2x, x is greater or equal 0. The normal to the curve at the point quarter pi as 0, the coordinates, shows that the exact area of the shaded region enclosed by the curve, the normal to the curve, and the y-axis. So they define the shaded area, the curve, y-axis, and the line is ln 904 plus 1 over 128 pi squared, which we have to prove. I have redrawn the diagram to mark the intersection of y and x axis. So OA, B, C, O is the origin, and y is 4 cos 2x divided by 3 minus sine 2x. So just to, okay. The shaded area, purposely separated. A shaded area is OAB, that is above the x-axis, and OBC, below the x-axis. OBC, clearly a right angle, triangle. So two sections. One is above the x-axis and below the x-axis. The above the x-axis, straightforward integration, and we know the limits and the curve equation, simple as that. So OAB is always y dx. So y, the integral of with respect to x, and the limit from the diagram 0 to pi by 4. So limit 0 to pi by 4 y dx. Y is 4 cos 2x divided by 3 minus sine 2x dx. Having got cos and sine, the denominator, so we can get the differentiation of denominator is in the numerator. So if the numerator happen to be differentiation of the denominator, then the quotient, the integral of that quotient would be straightforward log ln. Prior to do that, let's see the denominator. Take the denominator and differentiate how the differentiation of denominator come. So d of dx, 3 minus sine 2x equal. The differentiation of 3 is 0, and minus differentiation of sine 2x is cos 2x, and 2x, differentiation of 2x is 2. So that is the differentiation. So differentiation of the denominator is minus 2 cos. So this is equal to cos, minus of course, minus 2 cos 2x. But we have 4 cos 2x. We can make that as minus 2 cos. So all I did, I take minus 2 out from the numerator. If I do take minus 2, the inside, the numerator become minus 2 cos 2x. If you want it, minus to minus plus 2 times 2, 4. So it's same, no change at all. All I did, minus 2 out to make it, make the numerator is the differentiation of the denominator. So that's minus 2 cos 2x divided by 3 minus sine 2x. So we have the quotient, and the numerator is differentiation of the denominator. So straightforward. Minus 2 ln 3, so the ln of the denominator, 3 minus sine 2x, and the limit pi by 4 over 0, or 0 to pi by 4. If you could substitute that limits, or apply the limits, so minus 2 ln 3 sine 2x is 2 times pi by 4 minus ln 3 minus sine 2 times 0. Then minus 2 still, ln 3 sine pi by 2 minus ln 3 sine 0 is 0. Sine pi by 2 equal 1. So if we do that, that is minus 2 ln 3 minus 1 minus ln 3. So minus 2 ln 2 minus 3. If I take the minus inside, so that the sign change, so ln become positive, ln 3 become positive, ln 2 become negative. So 2 equals 2 ln 3 over 2. Then we know for, this is what we know, ln m time, sorry, not time, minus ln n, we can write it as ln m over n. So that is what we did here. So, and then if you have a ln b, that can be written ln b to the power of a. So that is what I did here. So 2 become the power of 3 over 2. So 3 over 2 squared is 9 over 4. So that is the area of the section above the x-axis has done. So to find the area of the section below the x-axis, it is, as I said, it's a right angle triangle, which is OBC, is half time base time height. Half time base is OC, the height is OB. So this is, but this is pretty simple, but we need to do a bit of work to find OC. OB is fine, it's pi by a quarter, pi by 4, but OC we don't know. So we need to find the line cuts the y-axis, therefore we can find the coordinate of C and OC. So in order to do that, we have to do a bit more work. We have given some information as well. The perpendicular, the line is perpendicular to the curve. So prior to go that far, the gradient of a curve, normally any curve, is dy over dx. So that is any point of the curve. But we need to find the gradient of the curve at the point B, which is quarter pi 0 point. So before we do that, you find the dy over dx, so the general form of dy over dx, so the gradient of the curve first, and then find the specific point, the gradient at a specific point. So y equal 4 cos 2x divided by sine 3 minus sine 2x. This is the coefficient form, is u over v form differentiation. So how I do it, how we do it, dy over dx is v, so the denominator 3 minus sine 2x, and the differentiation of the numerator, or differentiation of u, that is 4, but cos, differentiation of cos is minus, so I just put minus 4 sine 2x sine 2 minus then the numerator 4 cos 2x, and the differentiation of denominator, that is differentiation of 3 is 0, differentiation of sine 2x, so cos 2x times 2 divided by v squared, which is 3 minus sine 2x squared. Then having got that, now we need to find the gradient at a specific point, which is x pi by 4. So put the value x pi by 4 into that dy over dx, the general form. 3 minus sine 2 times pi by 4 minus 4 sine 2 times pi by 4, and the 2 minus 4 cos 2 times pi by 4 inside the brackets 0 minus 2 cos 2 pi by 4 divided by 3 minus 2 times pi by 4 squared. So pi by 2 we have said, I'll write it down first. So 3 minus pi by 2 is 2 times pi by quarter is pi by 2 times 2 there, and that 2 and minus 4 is minus 8 here. Minus 8 sine pi by 2 minus 4 cos pi by 2 inside the sine 0, that's remove the 0 or ignore the 0, minus 2 cos pi by 2 divided by 3 minus sine pi by 2 squared. So sine pi by 2 is 1 and cos pi by 2 is 0. So that is, if you could substitute all these values, 3 minus 1, sine pi by 2 is 1, 3 minus 1, minus 8 times sine pi by 2 is 1, minus cos pi by 2 is 0, the whole thing is 0, therefore we don't need to do anything further than that, just 0. And the denominator, 3 minus 1, sine pi by 2 is 1, 3 minus 1 squared. If we look at it, 3 minus 1 is 2, and minus 8 times 1 is minus 8, divided by 3 minus 1 is 2, 2 squared. So 2 squared, and that will be, let's say 2 squared is 4, 4 is common, that's 2. So 2 times 2 is minus 4. So minus 4 is the gradient of the tangent at B. So gradient of the tangent at B. What we need, the perpendicular line to the gradient at B. So, so we need to do a bit more. So if you have a perpendicular line, this is M1, this is M2 as perpendicular. M1, M2, these M1, M2 are gradient, gradient. That is minus 1. So this is, M1 is minus 4, we found it for the tangent. M2 is the perpendicular line, which we need to find. So M2 is quarter. So M2 is quarter. So the gradient of that perpendicular line is quarter. I just took the C, the coordinate of C, we don't know, just say x and y. This is arbitrary function, which you need to find x and y. And the B is quarter and 0. We can find the gradient between C and B, which is y minus 0 divided by, so the y coordinates is y for the C, and for B is 0 divided by x minus pi by 4. X is x minus pi by 4 at y-axis, x equals 0. That's what we put here, 0. 0 minus pi by 4. So if you could remove all the zeros, y over minus pi by 4 equal quarter, and just a little algebra work. The y times pi by 4 is 1 over pi by 4 become 4 over pi equal quarter, and cross multiplication, y is this. If that's the case, we know C, we don't need to go into C, but we want to write C is 0 and minus pi by 16. We don't need it. Anyway, so, right, the area of OBC is the right angle triangle. So half times base times this. So this one is half times OC times OB. OC is the distance from O to that C, which is positive. It's a distance always positive. So pi by 16. So half times pi by 16 times quarter pi equal 128 pi squared. So we have found the area of a triangle. We have found the area of the area under the curve above the x-axis. Then if you add them to, give us the entire shaded area. So this is the initially found the area under the curve by integration. And 1 over 128 pi squared, we after did some coordinate geometry, and we found the area of a triangle, which is 1 over 128 pi squared. This is exactly what we have been asked to prove, this one. So those of you would like to continue with the integration for the OBC, the triangle as well, of course you can do it. All you have to do, once you get the answer, you have to negate the answer. If the answer comes minus, you have to make it positive. So that is why I just did the triangle. So those of you would like to do it, so if you just simply that this line is what we found it line. The gradient of the line we found is quarter, so quarter x. It cuts the y-axis at minus pi by 16, so it's minus pi by 16. That's the equation of the line. Then it's just simply integration. You can do it. I'm not going to, well, if you want to. So the limit, this is 0, pi by 4, 0, and you can do it pi by 4 and y dx, of course. So this is the area of that, this area. So if you could write it, that's 0, pi by 4, and y is quarter x minus pi by 16 dx. Integration of quarter x is 1 over 4 x squared over 2 minus pi by 16 is the integration pi by 16 x, and the limits pi by 4, 0. This is, if you could substitute pi by 4, this is becomes, so pi by 4 squared is pi squared by 16. Here we have 8, so in other words, pi squared by 128. Please do it, I just jump in these steps. So just pi by x squared is pi by 4 squared, that is pi squared over 16. We already got 8 there, that's 120. 16 times 8 is 120, that is that one, minus. Then pi by 4 here, pi by 4, so 4 times 16, 64, and pi squared. So this is pi squared over 64. And then if you put the lower limit, which is 0, that will be minus 0. So this is going to be pi squared minus 2 pi squared, 2 pi squared divided by 128, and leave the 0. So the answer is minus pi squared 128. As I said, you have to negate the answer because of its area is positive. So this negative doesn't make any sense. So always this type of thing, you have to negate the answer. So answer is pi squared over 128. That is what we found it here by doing the area of a triangle. So those of you like to continue with the integration, of course you can do it. All you have to do, the final answer has to be negate. You can't take it as an area. Area cannot be negative, so it has to be positive. Thank you. Please subscribe the channel and share the contents with other students and friends. Those of you know, doing the A-level. Thank you. As I said before, please send some questions if you do require clarification, and I can make more videos. Thank you.